Good evening everyone, boys and girls. So yesterday we were discussing about quadratic equations, nature of the roots and also the relation between the roots and coefficients. Now by using that quadratic expression and the equation, now we are going to discuss some inequalities based on the same thing. Like quadratic equations, we are going to put it in the inequalities. So let us solve those kind of type of problems there. So hi, say hi in chat box everybody. Alright, so let me give the topics for the day. That are first one, that polynomials we are going to make. Polynomials we are going to make by taking the given roots. When they are giving the roots and factors, how we are going to make the polynomial, that we are going to see. And then intervals on a number line we are going to take, entire real number line we know. Okay, so how the variable x is going to change, as well as the interval is given to the x there. So we are going to discuss that also. And then Wavy curve method we are going to discuss. If there is a big expression with a lot of factors in that and there are powers more than 1, 2, 3 like that, then how we are going to find the values of x to solve that inequality. That is Wavy curve method. Factor theorem, when there is a polynomial, how we are going to find the factors to that polynomial. So how we are going to write that polynomial with using factors and all these things we are going to check. And then remainder theorem we are having. Remainder theorem means what kind of remainders we are going to get when you are going to divide a polynomial with another polynomial, a lesser degree that we are going to take. So before that, let me give the glimpse of the polynomial, how we are going to define and all these things. So a polynomial is an expression which contains one or more terms with non-zero coefficient. Like if we are going to see this here, the general form an x power n, an x power n, where an is coefficient, that is non-zero, and an minus 1 if I am taking, that is also coefficient, x power n minus 1 up to a naught. So before term also I am just writing so that you can understand how we are taking the expression here with variables x here and coefficients an minus 1, a1 up to a naught. So here you can see this n is there. If an is not equals to 0, then in this case you can say this is nth degree polynomial. So this is called nth degree polynomial. And the next, you can see that all these are coefficients here real and n is a whole number, then we can say n is the degree of the polynomial, right? And then note, n cannot be negative or fraction to be a polynomial. If it is fraction or negative, then it is not a polynomial. It is going to come under rational function or algebraic function that you are going to get in further classes. But for now we are going to take polynomial, and how we are going to write that one using the factors. Given roots if they are giving, then how we are going to write. Yesterday also I have given, when we are talking about the relation between the roots and coefficients, at that time I have given any quadratic expression ax square plus bx plus c. If I am taking the roots of this quadratic equation alpha and beta, then you can write ax square plus bx plus c is equals to a times of x minus alpha times x minus beta. The same way, if there are roots here r1, r2, r3 are the roots of a cubic equation, then you are going to write here x minus r1, which is a factor, this is one factor, this is also one more factor, and the last factor is x minus r3. And the coefficient here you can see a here, we can take any random coefficient here to be what? A cubic polynomial. Here we are taking r1, r2, r3 are the roots there. And now if you are taking conjugate pairs also, you are going to get, for example, there is a root here like 2 minus root 3 is there. Then your other root is going to be 2 plus root 3 if all the coefficients are real numbers. If you are taking 2 minus root 3i, then your other root will be 2 plus root 3i. These are conjugate pairs you are going to get. In this case, coefficients must be real numbers. In this case, coefficients must be rational numbers. Okay, so and the example you can see 2 comma minus 1 comma 3 are our roots of the polynomial with cubic expression here or cubic polynomial. Then you can just multiply this x minus 1, x minus 2, x minus 2, x plus 1 and x minus 3, and here we are going to get a here, right? So that is how you are going to define a polynomial when they are giving roots or factors. And then now you can see one factor is given x square minus x plus 1, and one more 0 they have given. 0 means that we can consider as a root also for polynomial equation. And they are saying that monic polynomial. I'll let you know what is monic polynomial here, whose degree is given by 4 there. and one more condition is there, P of 0 is equals to 1, we need to find P of 3. So P of x is equals to, you are going to write, we don't know the coefficient of x power 4, but they are saying that 4th degree, that is why I am going to write first one factor is given, that is x square minus x and minus x plus 1, okay na? And then one more 0 they have given, that means you can take x plus 2 here, okay? And it is a monic polynomial, that means monic polynomials means your coefficient of x power 4, x power 4 coefficient is equals to 1. Okay, so I think you understand what is monic polynomial. When we are taking this one 4th degree you are writing x power 4 coefficient must be 1 here. If you are taking 1, that is called as monic polynomial. Now you can see x square minus x plus 1 times x plus 2, because 0 they have given, minus 2 there, and degree 4, one more condition is there. Okay, now P of 0 is equals to 1. We don't know other factor, that is why I am just taking x minus alpha here. Okay, now I am just multiplying x minus alpha, because it should be what? Power 2 is there, 1 is there, 1 is there, total we have 4 here. To get this one 4th degree, I am just assuming one more factor for this one. To get the value of alpha, they have given that P of 0 is equals to 1. Let us plug in the value x is equals to 0 in the entire equation in this, and that is giving us P of 0 is equals to, this is going to be 1 here, and this is going to be 2, and that is minus alpha, which is given by 1. So alpha must be equals to what? Minus 1 by 2. Okay, now alpha you have got minus 1 by 2, you just have to plug in that value, then you are going to get P of x. P of x we have got, now we need to find what? P of 3. You just have to again substitute 3 in the given equation P of x, and you are going to get P of 3 is equals to, that is going to be 3 square minus 3 plus 1 and into 3 plus 2, and then 3 minus of minus 1 by 2, that is plus 1 by 2 you are going to get. On simplification you are going to get the value of P of 3. So that's how you are going to solve the polynomial equation or expression whenever they are giving the zeros as well as the factors for that one. One factor is they have given, that is why I am going to write like this. And then we have intervals on number line. This is very important topic. A lot of times in a lot of JEE questions, okay, now you are going to get this one, intervals on number line. Okay, now so first one is that when you wanted to take any variable which is lesser than some value, then how we are going to write it as interval, that we are going to show here. So if I am going to take x is between a comma b, then you are going to write open bracket here, that is called as open interval. Open interval is x belongs to a comma b. Let's say if I am taking x is lesser than 2 and greater than minus 1, then you are going to write x belongs to minus 1 comma 2. Right, the same way you can see closed interval you are having. If you are taking b comma a, both are including in this case. So x if I am taking between a comma b and a comma b also including, or if you am taking including a comma b, then the interval is going to be closed interval. That is the representation x belongs to, you can take a comma b. Right. Now semi-open if you are taking, one side it is open, one side it is closed. Either this one you are taking, or here you can say left open and left closed and right open. In this way also you can take. The last one you are going to consider as minus infinity when you are taking. So sometimes you can write the equation or like this inequality x is lesser than 1. In this case you can write x belongs to minus infinity to 1. Okay, now so that is exactly what I have taken. In this case here x belongs to minus infinity to alpha. You can write this one over here in the inequality form as x is less than or equals to alpha. Right, so in this way you can write the intervals, and the same way you can write beta to infinity also when we are going to take x is greater than or equals to beta. All these are the intervals. Now how we are going to use this one to solve the inequalities in quadratic equations and all these things, right? So let us see that. Right. So I am going to write the intervals for this one here. First one, all of you please give me the interval for this one. Come on guys, come on. You have to give this interval here. If x is greater than 1 by 2, how you are going to write? Right, so we just have to take the interval. I just have shown you how we are going to take open bracket and close bracket. Right, 1 by 2 to infinity, very good. That you are writing x is greater than 1 by 2, that is giving us 1 by 2 to infinity. Very nice. Right, so now what if I am going to take x is less than or equals to minus 4 by 5? You can write x belongs to, that is minus infinity to minus 4 by 5. Okay, now that is including. Right, so in this way you are going to write. And the second one, I am going to ask you, I am going to solve one question by using this inequalities, and the next question I am going to give for you, right? So the first one, you can see that x plus 5 is less than or equals to 2 into x plus 1. So you can take here that x that side, or x plus 5 entirely if I am taking that side. This is on the left side 0, and x if I am writing, that is 2x plus 2, and then this x I am taking on the right side, that is giving us minus x, and plus 5 also I am taking on the right side, it is going to give us minus 5. Done? So you can simplify further. 2x minus x is giving us x there. 2 minus 5 is giving us minus 3 is greater than or equals to 0. You can see that x is greater than or equals to 3. What will be the interval for this one? 3 to infinity, where 3 is including in this. Okay, now you can see that every value after 3 or including 3 will satisfy this equation, right? So that is how we are going to find the inequalities. Now a question for you. You can see that there are x's on the left side and right side, some values also added, and in the division also we are having. I am going to ask you to find the values of x here, which is going to satisfy this entire inequality. Okay, now by that time I am going to show you how an example how we are going to take the values of x here which are satisfying this. Let us take x is equals to 4. 4 you just have to substitute here. 4 plus 5 is giving us 9, and here 2 into 4 plus 1, which is giving us 10. So this is 10, this is 9. 9 is less than or equals to 10. Yes? So you are going to get the values of x like this, which are going to satisfy the given inequality. Right. What is the answer for second one? Right, minus 5 by 2 to infinity you are getting, very nice. Right, it is, let us check whether it is correct or not. You can see that 2x minus 3 divided by 4 plus 1, I am taking all the terms on the left side, which is giving us minus 2 minus 1 plus 4x divided by 3 is less than or is greater than 0. Now let us simplify on the left side here. You can see that you are going to have minus 1 here, minus 1, and taking LCM of these two, you have 12 there, and 3 times 2, which is giving us 6, minus 4 times 4, minus 16x there. Minus 16 minus plus 12 is giving us minus 4x, and then this is minus 9, and there minus 4, minus 9 minus 4 minus 13, should be greater than 0 there. Now again 1 you can take that side, minus 4x minus 13 if you are taking, greater than 1 and into 12, that is giving us 12 there. Now which is going to give us minus 4x is lesser than, that is going to be 25, and then x is lesser than minus 25 by 4. On simplification you are going to get the values of x there. You can see that x is giving us this. Okay, please cross check once again. I am giving that once again, I am cross checking that. 2x minus 3 divided by 4, 1 minus 2, and then 1 plus 4x divided by 3 there, LCM we are taking, 6x here, this is 6x here, 6x if I am writing, 6x minus 16x is giving us, that is going to be minus 10x there. Okay, nice. That is giving us here 10 and here 10, this is going to be 10 here, which is giving us what? Minus 5 by 2, correct? It is minus infinity to minus 5 by 2. Okay, na? So that is our interval, which is the solution for this one. Very nice. Many of you have got the answer. Very nice. Right. So let us see if they are giving a quadratic expression on the left side and there is an inequality, how we are going to solve. Whether it is greater than 0 or lesser than 0 or greater than or equals 0, less than or equals 0. When we have these kind of inequalities for quadratic expressions, how we are going to solve that. So quadratic inequalities we are taking now. The very first one is x minus alpha into x minus beta is greater than or equal 0. Then the values of this we are taking. In this case here alpha is lesser than beta I am considering. Alpha is lesser than beta. Then with an example I am going to explain how we are getting this interval here. I am taking x minus 1 I am taking, and here x minus 3 is greater than or equals to 0. I wanted to find the values of x which are satisfying this. Now you can see that what if I am taking on the number line, okay, so here 1 and 3 are the zeros of the expression, quadratic expression, right? So what if I am taking 3 plus, let us say 4 here, there is a number 4, 4 if I am substituting, 4 minus 1 is giving us 3, 4 minus 3 is giving us 1, 1 into 4 that is giving us positive number, 3 into 1 is giving us positive number. Between 1 and 3 I am going to take one number, 2 I am taking, 2 minus 1 is giving us 1 there, and 2 minus 3 is giving us minus 1. Those two multiplication is going to give us a negative number. Here it is negative, here it is positive. Similarly, if I am taking lesser than 1 value, so we can take 0 there. 0 if I am going to substitute, what do we get? This is 0 minus 1 is minus 1. 0 minus 3 is minus 3. Minus 1 into minus 3 is giving us again a positive number here. You can see the intervals, if I am taking 3 to infinity, the entire expression is giving us positive. If you are taking 1 to 3, that is going to give us negative. If you are taking minus infinity to 1, that is going to give us what? A positive number for this expression. That is why whenever you are taking greater than or equals 0, your values of x must be between minus infinity to, here 1 is there, here alpha is there. Here 3 to infinity, that is giving us beta to infinity. So simply you can write minus infinity to alpha and beta to infinity for the quadratic inequalities. Now the same way if I am taking less than or equal 0, so you can see that I have taken already, it is between, when we are getting negative this entire expression, when it is between 1 comma 3, the same way you can see it is between them. Okay, now 1 and 3 are including, because if I am going to substitute alpha here, that it is going to give us 0. That is why it is also included here, right? Now the next expression, if we are taking only greater than 0 or lesser than 0, lesser than when we are taking, we are not including alpha and beta there. When we are taking greater than 0, we are not including alpha and beta. So here we are having closed bracket which is including alpha. Here we are not including alpha, that is why we are taking open bracket there. Alright. So this is how you are taking quadratic. Okay, now I am going to give you a problem for you to solve, that is 2x square minus 8x minus 6 is equals to 0, plus 6 is greater than or equals to 0. Solve that one. Right, so I have given a very simple equation here, inequality, you can solve that. Okay. I am going to solve some more inequalities on that. Right, so I have given a equation here, inequality, which includes quadratic equation, and here this is not factorized here. You need to factorize and simplify further, right? Okay, so very nice. I am going to simplify this further. You can write this is x square minus 4x plus 3 is greater than or equals 0, which is giving us x minus 1 into x minus 3 is greater than or equals to 0. That is giving us x belongs to, so when is greater than or equals 0, your output here is going to be x belongs to minus infinity to 1 union 3 to infinity. Okay, na? The same way we can solve these problems here. 1, 2, 3, that is wrong. I think it is, yes, it is between minus infinity to 1 union 3 to infinity. Now you can see the same way, this one also we can write x belongs to, you are taking minus infinity to 3 union 5 to infinity. You have directly factors here, you can solve easily. So same way you can solve this question also by using the same concept, by taking the factors. Factors you just have to simplify. After that you are going to write entire inequality there, right? All the values of x there. Next we are going to take Wavy curve method. This is very important. Many questions you are going to have this one. Okay, na? So now let us see how we are going to solve the Wavy curve method when they are giving big expression. like when they are having powers for the expression. I am going to show you. You are going to feel like it is challenging questions. They are challenging questions. So step 2, we are having some steps to use Wavy curve methods here. That is factorize the expression. The given expression, just now I have solved a quadratic expression. We need to factorize the expressions. After that, we are going to find the roots or critical points. For example, if I am taking x minus 3 whole square into x plus 5 whole power 3. Now your roots are here. Roots are critical points, you can say 3 comma minus 5. Okay, na? So like that we are going to find out all the critical points on the real number line. We are going to write. How do you write this on the real number lines? Minus 5 comma 3, because 3 is greater than minus 5. And then use sign pattern alternative signs. That I am going to show you by giving an examples there. After giving examples, I am going to show you, right? And let us see this question here. What are the roots for this C1 here? A simple one, very simple one I am giving first. So the roots are 1 comma 2 here. Now if I am going to take more than 2 any value, that is going to be always positive. So always you are going to take more than this number, whatever the last one is there. We are going to write it in number line in ascending order. After the largest value, definitely it will be plus if the coefficients of x and x here 1 and 1. Okay, no? So and here plus. Then again, what is the power of x power 2? This is odd. If it is odd, then you are going to take changing of sign, that is minus. I am telling you once again that whenever the power of the expression or this factor is odd, this is odd, okay, now then you are going to change the sign of the entire expression. That is plus to minus, it is going. Similarly, if you are taking x minus 1, whole power 1 is there. Again there is a sign change here, that it is going to be plus. Now you can find out where it is negative. You can see that this entire expression is negative in one interval. What is that interval? That is x belongs to 1 comma 2. That is simple. Okay, now this one is very simple. I am going to show you one more example. Okay, now then after that I will give you a challenge of solving one more problem. You can see this very big expression is there. How many of you are feeling this is weird expression? Spam the chat box. You can see that x minus 2 whole square, right, x minus 3 whole cube and x minus 7 whole power 4. Power 4 is there, power 21 is there, power 19 is there. Yes, you can see that there are a lot of powers here and there are expressions in the base, right? X minus 2 is our base here for 2. And then, and here x minus 3, x minus 7 and x plus 2, x plus 4. Right, so how we are going to solve this? Right. So let us see how we are going to solve this. These are not options. We are going to find the intervals for this. Okay, na? So how we are going to be simplify. So I am taking all the numbers which are the roots here. You can see here 2 is there, here 3 is there, 7 is there, minus 2, minus 4. Okay, na? So all these numbers, if I am going to plot on the number line, we can see that minus 4 is our first number. After that we are having minus 2 there. And after that we have 2 and then 3 and 7. We just have taken all the numbers in ascending order on the real number line. As I told you, as all the coefficients of x here, this is positive, 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 positive. All the coefficients of x are positive. Directly you can take here, this is positive. More than the largest number if you are taking, then you are going to have what? Positive number. What if I am taking next to that? So it is going to be negative or positive. How we are going to confirm that? So you can see x minus 7 is there, x minus c whole power even is there. This is even. Okay, na? So as it is even here, this is not going to change. So the sign is not going to change whenever there is a even power for the root over there. So this factor is having power as 4 there. So there is no change in the sign of the entire expression. That's what we are taking there. Then if I am taking 3, 2 and 2 in between these two, 2 comma 3. So x minus 3 we are having here. This is here odd. Whenever odd is there, your sign is going to change here, plus to minus. So this entire expression in between 2 comma 3, it is going to be negative. You can check also by taking any value between 2 comma 3, like 2.5 you substitute and you check, you are going to get to know that it is always negative, right? After that, if I am taking x minus 2 whole power, again even is there. Whenever even is there is no change of sign. Let us take x is equals to 0. 0 if I am taking, this is positive, and this particular one is negative, and here negative, negative into negative, positive, this is positive, positive. Entire expression you are going to get it as what? Positive here. Sorry, this is positive, this is negative, positive, positive, positive. That means one negative is there, you are taking here negative. You can see that. So you just have to substitute the values between them and check whether it is negative or positive. Similarly, if I am taking minus 2 whole power 21 is there, which is odd, that is why I am changing the sign to plus here. Negative to plus you are going to get. And then afterwards we are having minus 4. Minus 4 if I am taking power 19 is there odd, so you are going to change again the sign here, that is going to be minus. Whenever the power is odd, you are going to change the sign, plus to minus or minus to plus. Whenever power is even, then you are not going to change the sign. You can see 2 times I have not changed here when x minus 7 is there and x minus 2 is there, because their powers are even there. Okay, now that is why we have not changed. Now we are going to find all the intervals for f of x is greater than 0. Wherever we are getting positive sign here for the entire expression on the real number line, we are going to take all those. So we have x belongs to minus 4 to minus 2, and the next one here union is representing the combination of all the numbers. Okay, na? And then we are having 3 to 7, 3 to 7, and union 7 to infinity. That is how we are going to take the solution for the inequality. This is entire solution of set of the inequality. Now all these values whatever there in these intervals are going to satisfy this inequality. You can check that. Okay, na? The same way if I am taking greater than or equals to 0, greater than or equals to 0, then you can write minus 4 is not in the numerator, minus 4 in the denominator. We cannot take in the denominator 0, because if I am substituting minus 4 in the place of x here, then it is going to give us 0. So which is not possible, that is why we are not taking there. So that is, so I am not including 4. But can I include minus 2? Minus 2 also is in the denominator, we are not including. But I can include 3 because it is in the numerator, 3 to 7. And 7 already included, so you can take up to infinity. Okay, na? So this is our solution set for x here to get the inequality solution, right? So to solve this inequality. Now the same way, f of x is lesser than 0 whenever it is negative. So when it is negative, x belongs to minus infinity to minus 4. That is our first interval. After that, union we have from minus 2 to 2 union and 2 to 3. 3 we are not, 2 we are not including because it is only lesser than 0. What if I am taking less than or equals to? When it is going to be equals to 0, I am going to take all the points where it is going to be equals to 0. So union at minus 2 also it is not 0, it is in the denominator, I am not including, but 2 you can include, union 2 to 3. Okay, na? So 2 is including in this case. I think 3 is also including, so we are going to write 3 also. 3 also including because it is in the numerator here. So you can substitute 3 here, it is giving us 0, which is satisfying the inequality. That is why I am taking 3 also. Right, I think everybody is waiting for the challenge here. So I am giving over here, try to solve this one, give the answer. You can see the question here. Minus 2 to 3, yes, we were taking that. I hope everybody is solving that. First you need to write the number line. Give me the number line first. Saket, I think you have a doubt in this, that if there are imaginary roots during factorization, how to point in Wavy curve method. We cannot take that. Whenever imaginary number is there, I am going to give an example for that one. We cannot find the factors and we cannot write the inequality there and solution for that one. I am going to show you. For example, x square plus x plus 1 is there. Okay, now. So there are imaginary numbers for this equation here. We cannot factorize this. Now this particular expression is always positive. This is always positive. Okay, now. I am going to give the conditions also. I am giving conditions. Very good. Now if x square coefficient, okay, now, positive, and I am taking, now as you are asking for the imaginary roots, very good Harsha, right, very nice. You have got the answer. Let me check that one. Very nice. Now here x square coefficient, if it is positive and b square minus 4ac is negative, then this, if I am going to consider, is f of x here. F of x is always greater than 0. Okay, na? So this is always positive. What if I am taking second case is that, what if I am taking x square coef is negative, that is negative, and I am taking b square minus 4ac is negative, means there are imaginary roots, then f of x is always negative. Okay, na? So these are the conditions for you. So if there are imaginary roots and we cannot make the factors there and get the inequality, directly you can take that is as positive and you are going to simplify the other factors. Okay, na? Now let me see Harsha's answer is correct or not. Right, I'm solving that. You can see what are the roots here. I am taking the first root as minus 8 by 3, which is lesser than minus 2, and minus 2, and here we have minus 5 also. I am taking minus 5 from the numerator. After that we have 3 by 2 and 21. So I am going to take 3 by 2 here, and there is 21 here, right? So as all the coefficients of x are positive, so why don't we consider this one here positive? Yes. So more than 21 when you are taking, you are going to get definitely positive. After that, if you are going to write here, there is a change of sign or not. Let us check that. X minus 21 whole power 1 is there, which is odd. So definitely there will be a change of sign. And after that 3 by 2 is there. 3 by 2 whole power 3 is there. Okay, na? So that is also odd. So there is a change of sign again. And then after that, what is the root here? Minus 2. Minus 2 whole power 2 is there. That is even. That is why there is no change of sign. And then minus 8 by 3 is there. Power 5, which is odd. Odd if you are taking, there is no change of sign. Minus you are taking directly. What if I am going to consider the last one, minus 5 if you are taking? Then for that one, you are going to have sign change or not? Minus 5 whole power 4 is there. That is even there. That is why there is no change of sign. So to be positive, what are the values we are going to consider wherever it is positive? X belongs to what we are taking? Minus 8 by 3, which is in the denominator. We are not including that. But we can include minus 2 or not. Minus 2 is also in the denominator. We are not including, because substituting of x is equals to minus 2, you are going to get in the denominator 0, which is not at all defined, right? So union, and then minus 2 to 3 by 2. 3 by 2 can we include? Yes, it is in the numerator. We can include that. Union, after that 21 to infinity. 21 is also included here. 21 because it is in the numerator. Right? If Sujata, very nice, you have got the answer. You can see that minus 8 by 3. Right. Please applause for Harsha and Sujata. All of you. They have got the correct answer. Appreciate them. Please appreciate them. Very nice. Right. So that is how you are solving wavy curve method. In the future, whenever there will be equations using this, today itself I have seen a question in areas chapter which using the same concept to solve the graphs and find the areas between them using integrations. So integration also we are going to get these kind of questions, right? Right. So next we are having factor theorem, right? So if I am taking p of x is any polynomial, okay na? Then if we are taking x minus r is factor whenever p of r is equals to 0. For example, I am taking x square minus 3x plus 2 is there, okay na, is equals to 0 for x is equals to what values? 1 comma 2, you know that. That means x minus 1 is factor, that we were studying already. X minus 2 is factor, right? The same way here, x is equals to r is satisfying this equation, p of x is equal to 0, then you can say x minus r is one of the factors. Now x minus a is factor of this, then how you are going to get the value of a? Please put your efforts to solve this, maximum efforts. It's very easy, you just have to plug in the value a here in the equation. Right? So plug in the value of a in this equation or expression, so that you are going to get is equals to 0 you need to take, because it is a factor there. So substituting the value of a here in this, you are going to get that, right? Okay, so considering this is p of x here, I am just writing that P of x is equals to x cube minus a square x plus 2 here, right? Minus 2, very good. A is equals to minus 2. A lot of people are getting very nice. Very nice. Srikar, Varshit, Bharati, Sujata, very nice. You guys nailed it. Right, Aditya, nice. So I am also giving the same thing, that P of A, if I am substituting, a cube minus a cube here plus a here plus 2 is equals to, we need to take 0. That means a is equals to minus 2. That is very simple because a cube is getting cancelled here, right? So that is how we are going to get. Definitely you will feel some challenging problems in the next slides here. Let us see. Next one we are having remainder theorem. Remainder theorem if I am taking. So whenever P of x is divided by x is equal x minus a, okay now, then your remainder will be P of a. I am going to prove that by giving the algorithm. You know algorithm of divisibility, that there will be dividend is equals to quotient into divisor, okay na, plus remainder, okay na. So this is how you are taking. Dividend is equals to quotient plus, times divisor plus remainder. This is algorithm. Same way, why don't I consider P of x as dividend, and we don't know quotient, that I am going to consider as Q of x. Divisor they have given. What is the divisor? X minus a is our divisor. So plus remainder we don't know, I am taking r. Okay na? So that is the algorithm for this entire expression when we are going to divide that. So I am just taking x is equals to a there. Then what do we get here? P of a is equals to Q of x times, here a if I am going to substitute, what do we get here? A minus a plus remainder. Okay na? So this is going to be 0 here. So what we are left with? R is equals to P of a. So P of a is our remainder. So that is exactly what we have given here. P of a will be the remainder when P of x is divided by x minus a. Or if I am taking x minus a is a factor, then P of a definitely is going to be what? 0. If P of a is 0, x minus a is a factor. Or if x minus a is dividing P of x, then the remainder will be P of a. That is exactly what I have proved over here. Then there is a question here. Okay, now before that I am going to give that when you are going to take here, this is P of x. Okay, now this is P of x I am taking. When you are going to divide P of x by x minus 1. So I am asking you to find the remainder P of x is divided by x minus 1. Okay, now I am asking for that. Please give me that. So when we are dividing x minus, when we are going to divide, right, again minus 2 you are getting, substituting minus x is equals to 1 in this, what do we get? Please check that. X is equals to 1 if you are going to substitute. Now I am not asking for the factors here. The factors you have already given, that is x minus 1 into x minus 2, very good. So I am asking when you are going to divide 1, because if you are going to substitute that P of P of 1 is equals to, you are getting 1. Okay now, the same way if you are going to divide with a quadratic expression, definitely there will be what? A linear expression as remainder. Linear expression we are taking. So I am writing here P of x is equals to x power 200 minus 2 into x power 199 plus x power 50 and minus 2 x power 49 plus x square plus x plus 1. Okay now, is equals to, we don't know the quotient here, is equals to, I am taking quotient there, quotient I am taking here, we don't know that part, but we do know what is the divisor, x square plus x square, then we are taking minus 3x plus 2, okay na, plus remainder we don't know, that I am taking as ax plus b. So are you able to see that part there? Ax plus b we are taking as the remainder because it is going to be a linear, right? So now how do you get that? So here I am writing q of x times of x minus 1 into x minus 2 plus ax plus b. Okay now? So then I am taking here p of x. Now I am just trying to substitute x is equals to 1. Substitute x is equals to 1 on both sides here. Then already you have got this value as 1 here on the left side. On the right side it is q of x times of 1 minus 1, what we are going to get? There 0. Yes, it is 0. Then smash this q of x entirely gone. We don't require the coefficient there, right? Now ax plus b is there, that is going to give us a plus b. A plus b is equals to what we are getting here in this case? 1. Okay, now we have got one equation in terms of ax plus b, a comma b, and I am going to substitute x is equals to 2 in this case. What if I am going to take in this 2 here? You can see 2 power 200 is there. 2 into 2 power 199 is there. 2 into 2 power 199 is giving us 2 power 200. 2 power 200, 2 power 200, both are getting cancelled. Okay, now then again I am going to write for your reference 2 power 200 minus 2 into 2 power 199. These two are getting cancelled. Then again plus 2 power 50 minus 2 into 2 power 49. These two are also getting cancelled. Then we just have left with what? 2 square, that is 4 plus 2 plus 1 is equals to, on the right side this entirely will be 0 because x is equals to 2 if I am going to substitute. 2 minus 2 is 0. What we are left with? 2a plus b. Okay, na? So 2a plus b is equals to, we have left with 7 on the left side. Okay, na? Right. Let me give that again. So this is 2a plus b on the right side. You can see that these two are getting cancelled, these two are getting cancelled. We just have left with 7 there. Okay, na? So a plus b is 1, 2a plus b is equals to 7. What will be the value of a then? A is equals to, you are getting 3. 3 if you are substituting, b is equals to what you are getting? Minus 2. You just have to solve these two equations. This minus this if I am taking, that is giving us a is equals to 6. 6 you are getting? Right. Okay, this minus this, b is getting cancelled, 2a minus a is giving us 1 and 7 minus 1 is giving us 6 there. And b is equals to, a is equals to 6 if I am substituting, b is equals to minus 5. So what is our remainder? Remainder is 6x minus 5. Okay. How many of you are liking this? Please give me the thumbs up in chat box. Right, whenever there is a quadratic expression here, which is the divisor, then you are going to end up with a linear remainder there. Okay, now that is 6x minus 5 in this case. Right. Thank you very much. Pradeep Reddy, you have got 6x minus. Varun, very nice. Gopal, please check once again. Thank you very much. Kishan, no worries. Quantum chill, no worries. I am going to give one more question. Maybe you are going to solve that one here. Okay, na? So here f of x is a monic cubic polynomial. So you can write f of x is equals to, you can write what? Monic cubic polynomial. This is a somewhat difficult question. This question appeared in JEE mains. Sometimes you can see that. Now how we are going to solve this one? By when they are giving the reminders. Okay, now how do we solve? So I am going to give the method. I am going to give one more question also, if possible. You can solve that one. Okay, now. So consider this the last question for the day. Now f of x is divided by x minus 1, x minus 2, x minus 3. What are the reminders that we are getting? Again 2, 3, 4. You can see 1 when we are taking, this is 2. 2 when we are taking, 3. And 3 when we are taking, 4. So there is a connection between them. One is increased. One number is increased when you are taking x minus 1. One number is increased when you are taking x minus 2. One number is increased when you are taking x minus 3. Let us see that f of x, if I am going to write, why don't I write here a into x minus 1 into x minus 2 into x minus 3. Okay, now when we are going to substitute, what is f of 1 is given by? F of 1 is given by 2 here because that is a remainder. What is the remainder when we are going to divide f of x by x minus 1? It is f of 1. F of 1 is given by 2 there. So 2 I am going to substitute here. Then again, when we are taking f of 2, that is also given as 3 here, and f of 3 is given as 4 there. So here 1 is increased. So if I am going to substitute x is equals to 1, this entire expression is giving us 0. So what else I need to add in this case? Now I am going to add x plus 1. So as simple as that, we are going to write here extra x plus 1. Why we are writing that? Because substituting x is equals to 1, this entire part is going to be 0. If I am going to take here 1, that is going to give us 2. It is satisfying for the second condition also. F of 2 is equals to 3. F of 3 is equals to 4. You can check that. If I am substituting in this, it is satisfying entire conditions. So all the reminders that we have taken as x plus 1 there, because every reminder is increased by 1, 2, 3 here. Okay, now for the given factors. That's what I am taking here. Now, what is A is equals to? A is equals to monic polynomial, already I have given. Whenever it is monic, A is equals to what? A is equals to 1. So our polynomial f of x is going to be x minus 1, x minus 2, x minus 3 and plus x plus 1. Okay, now which is satisfying every condition that they have given. Now what we need to find? When we are going to divide with x minus 4, so that is nothing but f of 4. Just we need to plug in the value 4 in the place of x. That is giving us 4 minus 1, 4 minus 2, 4 minus 3 plus 4 plus 1. What is the value of that? So you can see 1 into 3 into 2 into 1, which is giving us 6 plus 4 plus 1, which is 11. Okay, now? So 11 is our answer there. 11 is going to be the remainder when we are dividing f of x by x minus 4, right? Very good. Please show me your thumbs up in the chat box if you are liking this problem. 11, very good, Prajwal. Very nice, Harsha. Nice, Devisri. Sujata, very nice, Pradeep Reddy. Nice support, wonderful to see in the comments that everybody is liking this question. Very nice, very nice. Shall I give you one more problem on the same concept? Okay, now? Shall I give you? If you are ready, please let me know you are ready. Thank you, Sanjana. Very nice. Okay, I am giving last problem for you guys to solve. Okay, now? Let us take that. So I am giving f of x is a polynomial of degree I am taking 3 only, 3. So I am asking you to, if f of x is divided by x minus 1, a remainder is 1, x minus 2, a remainder is 4, and x minus 3 if you are taking, a remainder is 9. Okay, now? Then find the remainder when f of x is divisible by x. Okay, sorry, x, and not only x, I am asking you to find. Okay, I am just changing that x minus 4. Okay, na? So somewhat difficult. And when if f of 0 is equals to 8. F of 0 is equals to 8. You can find that. Okay, Saket, you have a doubt in this. Why do we take at the beginning? Because I was telling that when you are writing x minus 1, x minus 2, x minus 3, these are the reminders. Okay, na? Yes, I'll give you that, Saket. So when you are going to take here x minus 1, you are dividing with 1 there. Your remainder is 1 there. So if I am going to take this as a factor, you can conclude about 1 here, right? So you can add something else so that it is as going to be as a remainder, right? So consider that x minus 1, x minus 2, x minus 2, they are not factors. I am not writing as factor. We are just multiplying so that we can plug in the value x is equals to 1, 2, 3. So that we can conclude about remainder because they have given the reminders already. I think it is cleared, Saket. I hope. Please give me the like button. Please like the chart if you are liking this question, and if you are feeling challenging, please like the stream. Show me your love. Why only x plus 1? Where we have taken x plus 1? We have not taken x plus 1. Somebody has given at the beginning. Saket, I think it is clear. Okay, in the previous question, okay, fine, Rama. Nice. Very nice, Harsha. Thank you very much. I hope everybody is trying to solve this. X minus 1, Pradeep. Nice. Yes, Saket, I think same way I am going to give this one. X minus 4, very pinky. Pinky, you are getting 8, very nice. And Samba has got 8, very nice. And okay, let me check that whether it is correct or not. Kishan has got 12, very nice, very nice. 22, Srikar has got 22, very nice. Somebody has got minus 16, Devansh. Oh, 96, somebody is getting 16. Very nice, very good efforts you are showing. Very nice. Let us see whether it is correct or not, right? So I am going to solve this one by taking f of x is equals to, I am writing, we don't know the value of a because that is the coefficient of this, and degree 3 I am taking. So I am just multiplying all these 3, the divisors that they have given, x minus 1, x minus 3, x minus 2, and you can see that here 1 we are taking 1 here, 2 when you are taking 4 here, 3 we are taking 9 there. So that means you can take x square as the remainder for all these 3. Very good. Many of you have got the same thing, I think. Very nice. If you are writing the same expression, give me thumbs up button and like the stream. Very nice. I can see that chart rate is increasing by your answers. Very nice. Good efforts, guys. Show your energy. Give me the thumbs up if you have got the same expression here, x square. Very nice. Good, Lokesh. Very nice. Prasanna. Very nice. Now you can see that if I am taking a value we need to find, for that one I have given a condition there, f of 0, 8. You just have to plug in the value 0 here, a into that is giving us minus 1, and then next minus 2 and minus 3 plus this is 0 only is equals to 8 I have given. So what will be the value of a in this case? This is minus into minus into minus, which is giving us minus a again, that is minus 6, and on the right side if you are taking that is 8 by minus 6, which is giving us minus 4 by 3. Now you just have to take this one here, then you are going to get f of x is equals to minus 4 by 3 times of x minus 1 into, again we have one more factor, x minus 2 there, x minus 3, and the last part here x square. We just have to plug in the value here, x minus 4 we are dividing. When we are dividing x minus 4, you know the remainder, that is f of 4. So substitute 4 here, we get minus 4 by 3 into 4 minus 1, and then 4 minus 2, 4 minus 3, and that is 4 square. Let us see whose answer is correct on calculation of this. And then 4 square is 16, 3 is getting cancelled with this one, and 2 we have left with 1, 2 into 4 is giving us minus 8, and 4 square is 16. 16 minus 8 is giving us 8. Whose answer is correct? Give me the thumbs up and show me your love in the chat box. 8. Oh, a lot of people have got 8. Very good efforts. I can see that. It's a wonderful session that we are having. I can see a lot of energy in yours. Very nice. Very nice. I think you can challenge your friends with the same type of questions by giving the concept. Nice. Ganesh, Harsha, very nice. Right, Samba, very, very good. So I can assure you that you can challenge these kind of questions to your friends. Okay, na? So they are going to solve. You can amaze them by giving these kind of concepts. Okay, na? Whoever have not joined, you can share with them and you can challenge them. Please like the stream right now and share with your friends. Thank you very much for joining the session. And then, okay, I'm going to keep this one there. Okay, so yes, right. Thank you very much for joining the session. Bye bye. This is your personal math mentor Venkat Santosh from Chaitanya. Right. Thank you very much. See you again. Sir, sir.